Hello, in this video I'm going to present to you my version of the sheep behavioural analysis program. We're going to explore it from both within the C-line IDE and also within the command line interface. This program is written using ANSYS, and as you can see here, the appropriate flags have been set to ensure this. I will begin by performing a clean build which will flag up any errors and warnings if there are any. I will now run the program. A greeting message is displayed along with a summary of the default configurations which are assigned when ran within the IDE. If a user enters an invalid menu option, an appropriate message is displayed on the screen, as you can see here. If the default configuration is processed, no movements or behaviour inference will be completed. This is due to the current handling of 0 to 0 ranges for longitudes and latitudes. The user can provide a different configuration file. If an invalid file path is entered, an appropriate error message is displayed. If a valid file path is entered, this will be loaded and the program will run with this different set of configurations. As we can see, here are the default values that we had before, and here are the updated values that we just loaded in from our file. A summary of the GPS data file and a summary of the behaviours and movements generated are displayed. The generated movements are saved to the output file, so let's have a look at this. If we check against the configurations that we just set, we can see that the movement samples definitely satisfy the filtering constraints in this configuration. Scrolling through, we can see that there is a total of 408 movements that have been outputted to this file. As well as specifying a whole configuration file, you can modify individual configuration values. We'll start by specifying a different sheep collar file. If an invalid file path is entered, this is caught and an error message is displayed. If a valid collar file is entered, this will alter the current configuration value in the configuration settings. Here it has been changed to collar 15. The other configuration values can also be modified, such as the duration of movements. You can see the updated movement values here. You can also specify the maximum speed of the movements in meters per second. This again has been set. And you can also specify the longitude and latitude ranges. These will represent different geographical areas. Again, here you can see that it's been changed. We will now choose to go back to the main menu. You can process the now edited configuration values to generate a new set of outputted data. The summaries are displayed and the user is informed of where the data has been saved. It is saved in the same output file as before and has overrun the previous contents of this file. After refreshing the file, we can see that there are now 2,455 movement samples recorded, all conforming to the filtering constraints that we have just applied. These configuration values can be saved to a user-specified file in the configurations directory. As you can see, there are currently 2 configuration files in this directory. So a confirmation message is displayed. Let's quit the program and check that this new file is in this directory. We can see that it has indeed been saved for future access with the values that we just allocated it. This program can also be run on the command line interface with or without declaring a configuration file as an extra parameter. So first we navigate to the project source file and then compile this project to create an executable file which we're going to call runme. We can see that this has been created. The program will run just as before as it did in the IDE. So let's quit and we will run with the additional parameter of a configuration file. This executes the movement generation process before displaying a summary and displaying the menu as it did before. So we can see the summaries here, the current configuration status using the file passed in, which is obviously different to the default configurations that were set before. This pre-processing using a configuration file saves the user time if they already have a configuration file to process. Just as we did before in the IDE, the user can change values such as the maximum speed constraint. So we can change that to 0.4 and the value has now been updated. These updated configuration values can now be processed. If we look back to the previous configuration without the maximum speed constraint applied, there were 847 seconds worth of movement data. Now there is only 574 seconds due to the tighter constraint filtering. This updated configuration setting can now be saved just as we explored in the IDE before. A confirmation of this saved configuration file is displayed to the screen. We will quit the program and check that the out file and configuration files have indeed been saved when using the command line interface. So let's view the contents of the project and firstly check the configuration file. Looking here, we can see that it has been saved. Let's inspect it to make sure. We can see that it is correct with the max speed of 0.4 as we have previously applied. Going back to the project, let's check the contents of the out file. We can view the contents of the out file to check its validity. There are 163 movements recorded, which conform to the constraints that we have previously set. I have demonstrated the main features of this program via Elan and the command line interface. This was a very interesting project and I hope that this video gave you a clear insight into the functionality of this program.